Okay, all right. I am probably live and okay. So we're doing the last section today of the chapter 1 of linear algebra and its applications by Lay, and we are just going to hop into it. All right. So this one's going to be okay. The mathematical models in this section are all linear. That is, each describes a problem by means of a linear equation, usually in vector or matrix form. The first model concerns nutrition, but is actually representative of a general technique in linear programming problems. The second model comes from electrical engineering. The third model introduces the concept of a linear difference equation, a powerful mathematical tool for studying dynamic processes in a wide variety of fields. Linear models are important because natural phenomena are often linear or nearly linear when the when the variables involved are held within reasonable bounds. Also, linear models are more easily adapted for computer calculation than are complex nonlinear models. As you read about each model, pay attention to how its linearity reflects some property of the system being modeled. All right, constructing a nutritious weight loss diet. The formula for the Cambridge diet, a popular diet in the 1980s, was based on years of research. A team of scientists developed this diet after more than 8 years of clinical work with obese patients. The very low-calorie powdered formula diet combines a precise balance of carbohydrate, protein, fat, together with vitamins, minerals, and trace elements and electrolytes. Millions of people use the diet, okay, to achieve the desired amounts and proportions of nutrients. Dr. Howard had to incorporate a large variety of foodstuffs in the diet. Each foodstuff supplied several of the required ingredients, but not in the correct proportions. For instance, non-fat milk was a major source of protein, but contained too much calcium. Soy flour was used for part of the protein because flour contains little calcium. However, soy flour contains proportionally too much fat, so whey was added since it supplies less fat in relation to calcium. Unfortunately, whey contains too much carbohydrate. I really like this problem. This problem is really fun. The following example illustrates the problem on a small scale. Listed in Table 1 are 3 of the ingredients in the diet, together with the amounts of certain nutrients supplied by 100 grams of each ingredient. If possible, find some combination of non-fat milk, soy flour, and whey to provide the exact amounts of protein, carbohydrate, and fat supplied by the diet in one day. So this is the column of the desired. You want 33 grams of protein, 45 grams of carbohydrates, and 3 grams of fat. That's pretty slim for a whole day. You're eating basically nothing, man. All right, so x1 through x3 denote the number of units of the foodstuffs. One approach to this problem is to derive equations for each separately. For instance, right? So if you think of it as a vector, x1 is 100 grams of non-fat milk. All right. To this amount, we would then add similar products for soy flour and whey. saying this resulting sum equal to the amount of protein we need. Analogous. All right. I mean, this is like so obvious. Yes. Here we go. 33, 45, and 3. Okay, they round. They find the answer. That's great. It's important that the values of x1, x2, and x3 are non-negative. That was one thing that was interesting about this problem, is that there's actually a constraint on the solutions. Okay. The amount of nutrients supplied for each foodstuff can be written as a scalar multiple of a vector. They say this word linear programming, but I don't even know what that means. Okay, linear equations and electrical networks. This one I didn't actually understand when I tried to read it. All right, current flow in a simple electrical network can be described by a system of linear equations. A voltage source, such as a battery, forces a current of electrons to flow through the network. When the current passes through a resistor, some of the voltage is used up. By Ohm's law, this voltage drop across a resistor is given by the resistance times the current. The network in figure 1 contains 3 closed loops. The currents flowing in loops are denoted by I1, I2, and I3. The designated directions of loop currents are arbitrary. If a current turns out to be negative, then the actual direction of current flows opposite to that in the figure. If the current direction shown is away from the positive longer side of the battery around to the negative, the voltage is positive. Okay. Otherwise, the voltage is negative. Current flow in a loop is governed by the following rule. The algebraic sum of the Ri voltage drops in one direction around a loop is equal to the algebraic sum of the voltage sources in the same direction around the loop. Determine the loop currents in the network. Okay, so this is definitely going to be on the test on Thursday, so I might as well understand it. So for loop 1, the current flows through 3 resistors. So yes, we have 4I1, 3I1, or 4I1. So we get 11I1 is equal to the voltage drops of all 3 of those. However, current from loop 2 also flows in part of loop 1 through the short branch between A and B. The associated Ri drop there is 3I2. Therefore, okay, and we know this is 30 volts. However, the current direction for the branch AB in loop 1 is opposite. Oh, interesting. Yeah, you got to pay attention to that. Is opposite to that chosen for the loop in for the flow. So the algebraic sum is 11I minus 3I2. Since the voltage in loop 1 is 30 volts, Kirchhoff's voltage law implies okay, and then we get the equation number 2. 2 is going to be 1, 2, 5, 6. It's going to be 6i2. Yeah, minus 3i1. And then, see, this is what I don't get. Because here, how does this work? It comes and it hits this thing. So this loop is going to be, I think it's actually going to be, I think that this is, so this is the positive to negative. I don't know how this works. This third loop is weird to me. So I understand that loop 1 is 30 volts is equal to 11 times the current through the first loop minus 3 times the current in the second loop. Then 2, we have 5 volts is equal to 6i. Wait, actually, hold on. So the negative 3i1 comes from the loop 1. The 6i2 is the sum of the resistance in loop 2 multiplied by the loop current. The minus i3 comes from loop 3 flowing through the 1 ohm resistor in branch CD. That's so confusing. But okay. Okay, so then I3, we're going to get 20 is equal to 3i3 minus I2. Oh, yeah. Oh, but see, that's what I was thinking, is it's not going to be 20, it's 25. Because the algebraic sum of the voltage drops around in one direction around a loop equals the algebraic sum of the voltage sources. And since these are opposite, wait, it's minus 25? Oh, because the loop direction is going that way? I don't know. That one's weird. It is instructive to look at the system as a vector equation. The first entry of each vector concerns the first loop, and similarly second and third. The first resistor vector R1 lists the resistances in the various loops through which current I1 flows. The resistance is written negatively. Yeah, that's fine. Examine. Ugh. If all loop currents are chosen in the same direction, then all entries off of the main diagonal of R will be negative. Each equation here corresponds to the circuit with only one voltage source. Yeah. Okay. So that was electrical circuits. Difference equations. Okay, so you have an iterated map, which just happens to be a matrix vector multiplication. Yeah, actually, the behavior of linear difference equations is pretty interesting, I feel like. All right, so then here they talk about initial value problem. Okay. Movement of populations. Simple model here considers the changes in the population of a certain city and its surrounding suburbs. So fix an initial year and denote the populations of the city by R0 and S0. So this is the initial condition. And subsequent year for 2021 and subsequent years, denote the population of the city and the suburbs by excellent blah 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 blah. Our goal is to describe mathematically how these vectors might be related. Supposed demographic studies showed that each year 5% of the city's population moves to the suburbs and 95% remains in the city, while 3% of the suburban population moves to the city. After 1 year, we get um, okay, so this is called the migration matrix. What I'm curious about is the steady state, though. What is the steady state of migration matrices? So basically you have calls sum to 1. All right, so let's go to Chat GPT, bro. So if I have a linear diff equation with a migration matrix where columns unital sum to 1, what is the steady state? Okay, that didn't really help me, but that's cool. What if we just did this? What was it? 0.95, 0.97, 0.05, 0.03. That thing. I don't think that's right. Oh wait. Okay, so basically what we want to know is like the flow to the city is going to be 0.95 x1 plus 0.03 x2. So that's the flow into city. Now the flow into the suburbs is going to be 0.05 x1 plus 0.97 x2. Flow to suburb. That's interesting. I like the migration matrix thing. That's fun. Okay, find a matrix. Okay, I already did it. So this one, oh, I did this one already. But example one, it's basically find a matrix. The matrix is this is A, this is B. So X is right here, and we can go to the answer. The answer is right here. A, X, B. All right, so these exercises will probably be pretty fun. All right, let's get to exercises. The container of a breakfast cereal usually lists the number of calories and the amount of protein, carbohydrate, fat in one serving. The amounts for two common cereals are given below. Suppose a mixture of these two cereals is prepared that contains exactly. All right. A mixture that's not 295 calories, 9 protein, 48, and 8. So that's the bias. Or I don't know what you call it. B. Whatever B is called. Set up a vector equation for this problem. Include a statement of what the variables mean. Okay, so x1 means the number of servings of cereal 1, and the vector is going to be the nutrition information for that cereal, plus x2 of 133, 18, and 5 is equal to 295, 9, 48, and 8. Okay, so this is the vec equation. Write an equivalent matrix equation. 110, 130, 4, 3, 20, 18, 2, 5, x1, x2 is equal to 295, 9, 48, 8. I don't even know why I wrote that down. Then determine if the desired mixture of the two cereals can be prepared. Okay, so we're going to do an aug, and this is going to be 110, 130, 295, 4, 3, 9, 20, 18, 48, 2, 5, 8. Okay, wait. Oh, no. Okay. So if I did okay. So it's right. So yes, it can. One serving of post-shredded wheat supplies 160 calories. Jesus. Okay. So we have 165, 6, 2, or 1. And then we have 110, 2, 0.1, 0.4. Okay, so then we want to find all right. Okay, and then b is equal to, let's just write this down so we can do this really quickly. 130, 3.2, 2.4, 6.64. Okay, so let's just do this thing. So first off, we're going to have og is equal to 160, 110, 130, 5, 2, 3.2, 6.1, and 2.46, and 1.4, and 0.64. Our ref of this augmented matrix. Okay, yes. Okay, and the first one is going to be 3 aug 1 719 18.2 and 3.8. All right. Yes. Great. All right. So we did that problem. So number 2 is done. Let's just read through the. After taking a nutrition class, a big Annie's mac and cheese fan decides to improve the levels of protein and fiber in her favorite lunch by adding broccoli and canned chicken. The nutritional information by a table. What is shells? Oh, it's an alternate. Okay, I'll fine. Because it's such an easy problem. 270, 51, 70, and then we'll have the alt is 269.5. Okay, then 10, 5.4. You know what? Why am I doing this? Well, whatever. 5.4, 15, and 2, 5.2, 0. And then what does she want? She wants we're just doing linear algebra. It's a linear algebra textbook. It's linear algebra and its applications by David Ley. And we're doing section 1.10, which is linear models in business, science, and engineering. Okay. Okay, and what did we want? The requirements for B was that she wants 400 calories. She wants 30 grams of protein, 10 grams of fiber. Okay, so let's do this. So we have A is equal to, you're good, bro. You're good. 270, 51, 70. Okay, what is the question? The question is what proportions? So we should just build we'll do this. 70, 10, 5.4, 15, 2, 5.2, and 0. Okay, then we have B is equal to 430 and 10. And then the alt is 260, 9, and 5. Okay, so the first thing we're going to do is RF of HCAT A and B. And we find that we need that many servings. So what was the question? The question was, what proportions should she use? So for A, it's x1 0.985 or something. x2 is equal to 1.54, and x3 is equal to 0.78. Great. Now the next thing we want to do is we want to do HCAT A to the end. So we want to HCAT alt to the end B. Okay, so that's a new matrix, and now we want to RF this. Okay, and so then for B, we want x1 is equal to 1.088, x2 is equal to 0.875, and x3 is equal to 1.03. All right, so that was pretty easy. These problems aren't that fun. I thought there was going to be... I want to do the electronics ones. I think those are going to be way harder. Because that was hard for me. All right, let's just skip to that. All right, so we're going to do number 5. So so for number 5, we want to write the matrix equation and then solve it. Oh my gosh, this is a big system. Oh, dude. So, okay, so I think... So I think for the first equation, we're going to get 50 volts. So we're doing number 5. And then, so 50 volts, I think it's sums because the negative and the positive are connected next to each other. So I think that this should add, not subtract. Let me check for this one. Yeah, so they added. Do you see that? They added. The positive was connected to the negative and they added them. So we're going to get 50 volts is equal to 1, 6, 10, 11. 11I1 minus 5I2. Okay, the next one is going to be dude, these diagrams are really not good for me. All right, so we know it's going to be 8, 9, 10. We know it's going to be something 10I2. I'm trying to think. They're all all the arrows are pointing the same way, but the current sources or the voltage sources are not. See how they flip? All right, these are good exercises to do because I hate these. So you're gonna have 30 volts going through here, right, on this loop, and the current is gonna be flowing this way. So I think it's gonna be a plus 5 I1, right? So it's gonna be 10I plus 5 I1. Oh, so I think the other one is a plus as well. Because the current's flowing in the same direction. So I think it's going to be 40 volts is equal to 10I2 plus 5I1 plus I3. Because we have this loop. This loop includes 40 volts and 1, 2, 3, 4, 10 ohms. Okay. So this one, current is flowing this way. So I think we're going to get 30 is equal to 6 plus 2 is 8, 9, 9I3 plus I2 So we have 30 volts, but then this thing, which is also 30 volts, so I'm going to say plus 2I4. And then for equation 4, 30 volts is equal to 3, 6, 10I4 plus 2I3. Oh, I think I got that wrong. I think I flipped a bunch of signs. I don't think that's right. I need to go look at the example. This is taking too long. So you did finish it? So it did do 11 minus 5. Bro, I really don't like these ones. See, that one genuinely looks opposite, though. Okay, hold on. Current from loop 2 also flows in part of loop 1 through the short branch between A and B. The associated voltage drop there is 3I2. However, the current direction for branch AB in loop 1 is opposite to that chosen for the flow in loop 2. That's what's weird to me is this choice of direction of the loop. Like, okay, so the direction of current flow, the designated directions of such loop currents are arbitrary. That's why I feel like my equations might be right, even though I did sums on everything. Now I want to see if it gets this one right. Okay, so since the voltage in loop 1 is 30 volts. Right, because this is the loop and there's only one voltage source in that loop. So we get 30 is equal to 11I1 plus minus 3I2. Loop 2 now. Loop 2 is also going to be easy-ish, right? So there's only one voltage source in that loop. So it's going to be 5. Okay, so we're going to get 1, 2, 5, 6. So we're going to get 6I2. And we're going to subtract 3I1. Right, okay. And then this is going this way, but this one's going this way. Or wait, no, this one's going this way, this one's going... So then we want to do minus I3. You don't look at the direction of the voltage source. You look at the direction of the arrow. And if you're given the arrow, then you can do it. So, okay, so wait, the last one's the most important one because this is the one that is going to trip me up. Okay, so the last one, the current is going this way. So we have 20 plus 5. I guess it doesn't matter which direction these are going. I don't know. The term... The loop 3 equation is minus. Okay, so yeah, so let's try to set this up. So number 3, we get so we're gonna get 3i3 minus I2, and this is gonna be equal to minus 25 volts. But they added. That's what's so weird. They added together. Let's see, did they get the right thing? No, see, it didn't do it right either. This one is right. This one is wrong, sort of. All right, so bro, these are like significantly harder to translate into equations than the other ones. At least for me. Okay, so all right, so let's look at this one again. So I do believe that we are going to get 50 volts here, right? Oh, but this is a minus. Okay. Okay, so I'm pretty sure that the second one, you're going to get 50 volts is equal to 6, 10, 11, 11I1 minus 5I2. Okay, so it seems like okay, I think it should be minus 40. We should start solving some of these because I'm pretty sure that okay, so then we get 2, 7, 10. So I think it's going to be equal to 10I2. Now, since the current's flowing this way and this one's flowing this way, then it's going to be minus 5I1 minus, I think, because this current is going to be flowing this way. So it's going to be minus I3. Now this one is going to be 30 is equal to 3, 7, 9. 9I3 minus I2. minus so this current's going this way, this current's going against it. So this is going to be minus 2I4. Now, this last one, the current's flowing this way, so I think it's going to be minus 30. And then we have 7, 8, 10. 10I4 it's just going to be minus 2I3. So if we write this in matrix form, we're going to get 11 minus 5, 0, 0. Then minus 5, 10, minus 1, 0. Then we're going to get 0, minus 1, 9, minus 2, 0, 0, minus 2, 10 is equal to 50 minus 40, 30 minus 30. Holy cow. It's already 1. This is not good. Damn, I just don't know if it's right. All right, let me write them down now. Okay. All right. All right. Now that we've done one, I feel like I can do it. I can do it because I know what to do. I just don't know if it's right. Like six looks easier actually because there's only one voltage source in each loop. So this is just going to be 30 is equal to 6I1 minus I2. Then I2 it's gonna be 9. So it's gonna be 20 is equal to 9i2 minus I1 minus 4i3. 40 is equal to 7i3 minus 4i2 minus 2i4. Now 10 is equal to 7i4 minus 2i3. Okay, so then the matrix is going to be 6 minus 1, 0, 0. What did it say about the... All right. All right, let's just. Okay. So 7. So in the loop, there's only one still. So and the current's going that way. So we're gonna have 40 is equal to 12 I1 uh minus 7 I2 minus 4 I4. Okay. Then for I2, we have 30 is equal to. We need to be careful because I think in this case, this is supposed to be a minus 10. Like here, it's going the opposite way of the. Okay, so you got to be careful with that. But I think that so far we're good. So we're going to have 30. 8 plus 7 is 15. 15 I2 minus 7 I1. And then it's going to be minus 6 I3. Now I3 is going to be 20 is equal to 11. 14 I3 minus 6 I2 minus geez, I just look at these diagrams and I glaze over, man. Minus 5 I4. And then I4, it's going to be minus 10 is equal to 13 I4 minus 4 I1 minus 5 I3. All right, so let me just write that down. 12 minus 7, 0 minus 4. Minus 7, 15 minus 6, 0. 0 minus 6, 14 minus 5. And this is going to be minus 4. What was it? 13? God. Okay. I mean, that sort of. I don't know if it's right. Okay, we're gonna skip number 8 and we're gonna do number 9. All right. In a certain region, about 7% of a city's population moved to the suburbs each year. Okay, so on the off diagonal, we have 0.07 and 0.05. And so then we have on the diagonals 0.93 and 0.95. 800,000 and 500,000. Set up a difference equation. Then estimate the population in the city 2 years. Okay, so we're just going to do this. I'm pretty sure that you can do, so if we have A is equal to 0.93, 0.05, 0.07, 0.95. I'm pretty sure if you have like let's do this. I'm pretty sure A, let's do, okay, x1 is equal, yeah, and then let's do that. I'm pretty sure that's the same as saying A squared times x. Yeah, so that's what I thought. So there we go. So we did that. I'm going to skip 11. Hold on. This one seems great. All right. So the initial condition for 11 is 20, 100, and 200. A truck rented at one location may be returned to any of the 3 locations. Yeah, I don't understand. I think that this is a bug in the. I think this is not supposed to say that, but I think this is supposed to say Pullman, Spokane, and Seattle. Because that doesn't make any sense otherwise. But anyways, let's was the initial condition? Does this work? Study how changes in boundary temperatures in a steel plate affect the temperatures into estimating the temperatures. Okay, I think we'll do these before the test. So we'll do the supplementary exercises before the test. But we did most of 1.10, so we're good there. All right. Okay, so I think I'm still planning to do a differential equation stream in maybe like 30 minutes or something. I might eat. I'm gonna do the homework, and then we'll start.